Okay, the sum of an infinite geometric series. Okay, you can read example 1 on your own. That is just finding a partial sum of so many terms, blah, blah, blah. It talks about that. You can figure that one out. For infinite geometric series, if the common ratio is less than 1, or between -1 and +1, non-inclusive, so the absolute value of that ratio is less than 1, then it has a sum. Okay, if the absolute value of the common ratio is greater than or equal to 1, there is no sum, because that means it's like an exponential growth. It's just getting bigger and bigger and bigger forever fast. Okay, but this one is what's called a convergent. It's a convergent series, meaning it's going to converge on this one point. It has a limit necessarily. Okay, so and you use this formula, you have to be able to identify what the common ratio is. Okay, and then you just use the formula to find the sum. Okay, now here are 2 or 3 geometric series. Okay, this one we have a common ratio. If you're ever given this in this form in summation notation, this number that's being taken to this power, that is your common ratio. That is R. Your first term is this number here. So A sub 1 is 5. Your common ratio is 0.8. And you use your formula. S sub n equals 5 over 1 minus 0.8. Okay? And then you just do the math on that. 5 divided by 1, or divided by 0.2, which is 25. So this series will approach 25. Okay. The next one, they're giving you it in the regular notation, not in summation notation. So what you have to do is you have to find the common ratio. Well, it's -3/4 over 1. Okay, you can keep checking that. Okay, it's 9/16 over -3/4. Okay, when you do that, you're going to get -3/4 as your common ratio. So R equals -3/4. The absolute value of -3/4 is 3/4, so it does have a sum. Okay, so here we go. The sum is going to equal 1 over 1 minus the common ratio, which is -3/4. So it's 1 over 1 plus 3/4, or 1.75. If you want to deal with the decimals, that's fine. So 1 divided by 1.75 is going to equal, I don't want to deal with the decimals, that's just gross. So it's 1 plus 3/4, so it's 1 and 3/4, which is 7/4. 1 divided by 7/4 is going to be 4/7. So that's the sum. Remember, decimals are gross. They're always gross. This one, if we look at it, we're given in summation notation. The common ratio is 5 over 4. Well, what's the absolute value of 5 over 4? It's 5 over 4, which is more than 1, right? There's no sum. No sum. Okay? Because that number right there, the absolute value of 5 over 4 is greater than or equal to 1. No sum. Next one, write as a fraction in lowest terms. These are all repeating decimals. Repeating decimals can actually be rewritten as the sum of a geometric sequence. So we can actually use that as a method to write the fractions. Basically what this one is the repeating part has 2 decimal places. So we can actually represent this as a series of 24 times 0.01, 2 decimal places, plus 24 times 0.01 squared, to the first, to the second, to the third, and so on and so forth. Okay, we can keep writing it like that. So if we want to use the summation notation, okay, we can. The first term of this series is 24 over 1 minus 0.01. That's 0.24, not the first term. Sorry, the first term in this series is 0.24. Okay, then when we do that, we've got 0.24 over 0.99. Okay, if we want to deal with integers, we can just change this to 24 over 99. That's multiplying the top and the bottom by 100. That's a legal move. We can do that. And then to reduce that fraction, you can divide both by 3. We've got 8 over 33, and that's as far as it can go. Okay. So we just took this repeating decimal and we converted it to its fraction form. This one, here's a repeating decimal. You might know this, some of you might know this, but basically your common ratio, instead of it being 0.01, it's going to be 0.1. So this is going to be 5 times 0.1 plus 5 times 0.1 squared plus 5 times blah, blah, blah. Okay, so we use the summation notation, or the sum formula. 0.5 is the first term over 1 minus 0.1. So we've got 0.5 over 0.9. Make the numerator and denominator integers. 5/9. Okay. Next one's going to be just like this one, and I think I'm going to stop there. You can figure that one out. You're going to just follow this formula again.